Hi all, welcome to my YouTube channel Easy Coding with Ankit. Today we will solve Leetcode problem. Let's get started. So today's problem is next permutation. Problem number 31. It's a medium time problem. Let's see this problem in Leetcode first. So in the description mention a permutation of an integer array of integer is the arrangement of its member into a sequence or linear order. Let's consider array is 1 2 3. The following are the permutation of a array that will be 1 2 3, 1 3 2, 2 1 3, 2 3 1, 3 1 2, and 3 2 1. So what we have to do in this format, let's say the array will contain 1 2 3. We need to find the next permutation here. So this is the sequence. So if the array is containing 1 2 3, the next sequence will be 1 3 2. If array is containing 2 1 3, the next sequence will be 2 3 1. Like that we have to find the next permutation. Example are also given. Next permutation of array 1 2 3 is 1 3 2. So here 3 will be placed at 1, placed at 2, and 2 will be placed at 3. So that's the only changes here. Similarly, array of 3 2 1 is becoming 3 1 2. So you can see 3 2 3 1. After that 2 3 1. The next permutation is 3 1 2. Well, if array is containing 3 to 1, that means the last permutation in the sequence, then it will become the first one. That will be 1 2 3. So that's we have to find out. We'll be giving array with some number. We have to find the next permutation of this. In example, you can see 1 2 3. The output will be 1 3 2, and the replacements must be in place and use only constant access memory. So we don't have to create a new array. We need to change this in the same array and don't have to return it, because in the function also you can see it's a void type. Let's just question, given an integer num, find the next permutation of nums. So how we will solve this problem? Let's discuss this first. So to find the next sequence, we need to change the order. Let's consider the first scenario where array is containing 1 2 3. So what we will do first, we will identify two indexes. First index where the first value is greater than second value, and we will start from checking from the last index of the array. So here array is containing 1 2 3. So from the last we will start checking, and we will try to find if, let's consider this one is index I. So I index array of index I is greater than, less than, basically array of index I plus 1. If this scenario is true, then we can take this as a first pointer. We will need to find two pointer. First, based on this condition, we will find the first pointer. Second, we need to find a value which is greater than this one. So if we find from the last, value greater than 2 is 3, so it will be same only. So this value will be taken as a second pointer. So first pointer will point to 2 and second pointer will point to 3. And these two value, we will swap it. Once we swap, it will become 3 and 2. That's our output. We are just basically changing the order, and based on that we will find the next. If we have some bigger array with bigger numbers, like let's say array is containing 3 4 2 1, and output will be 4 1 2 3. So here you can see 4 or 3 is changing the place. First 4 2 1 is that, then 4 will be at the first position, that will become, and rest will be in ascending order. So it will become 2 1 2 3. So that we have to change. So same way what we will do, first from the last we will start finding the number index where if it is less than the next value. So here 1 and 2 we will compare. 2 is less than 1, no, not is, that is false. 4 is less than 2, that is also false. 3 is less than 4, that is true. So this we will take as a first pointer. Again we will start from the last and check if any value is greater than this 3. So 1 is greater than 3, false. 2 is greater than 3, false. 4 is greater than 3, that is true. So I got the second pointer also. These two we have to swap. So 4 will be placed at first location, 3 will be placed at second location. After this, what we have to do, we need to pass the pointer once with which we have replaced. So we have changed with for first index, zeroth index, 0 plus 1 we will pass, and then what we have to do, we have to reverse the rest remaining number, because we have to again make it as a ascending order. So for that we will be reversing this whole array, and we will start from third value. So 3 and 1 will be, how we will replace, one by one we will be, um, what we will do, we will take first element from the start and we will take second element from last, and those two will be swapping, and then again we will, this index will be incrementing and the second one will be decrementing, like that we will be one by we will be swapping those, and after that it will be becoming ascending order array. So after swapping 3 and 1 it will become 1 to 3, and that is the our answer, that's the correct order of next permutation. Let's take one more example. If array is containing 3 to 1, which is the last permutation, after that it should be the first one. So here what we will do, we don't have to find those two pointer, we just, what we will do, we will just reverse the whole array. So after reversing it, it will become 1 2 3. So those two things we have to do. First we have to find two pointer. If we are getting those two pointer, then we will be swapping those two, and after that we will reverse it. If we are not getting, let's say we have reached at the end of the array, then in that case we know we don't have to swap it, we will just reverse the array. Let's write the code for this and see how it is working. So first, to find out two pointer, we'll take this as an index 1, which will be a -1 or anything we can take, because that will be changed later. And then index 2 also -1. First we have to find a index where that index value is less than the next index. So we will take int I equal to nums dot length -2, because we will be comparing with the next element. So I'm not taking -1, I'm taking with -2, so I can compare with -1 also. Array getter or equal to 0 I minus minus. Inside this we will check for the number nums of I. If it is less than nums of I plus 1, I'm taking as I plus 1, that's why I've taken 2 length minus 2. If it is true, if this condition is true, then we will store this value in index 1. Ith value we will be storing, and we will be breaking from this loop because we got our first pointer. Now we have to find the second pointer. What we can do, if we are not getting any pointer from here, that means index 1 is 0, that we can check. If index 1 is equal to -1, because -1 I have taken as a default. If it is not coming inside this if condition, then by default it will be -1. So if it is -1 index 1 value, then what we will do, we will just reverse the array. And for reversing, what we have to do, we have to pass the array first, and we have to also pass the index number from where we wanted to reverse it. We will pass 0 index here. In else case, we will write this logic, reverse logic, we will write later. So we are just reversing it as we have discussed earlier. Now we have, if this array of index 1 basically is not equal to -1, then we have to find the second point. How we'll find it? We will check from again from the last array of nums dot length -1, I is greater or equal to 0 and I minus max. Inside this, we will check if any number nums of I is greater than nums of index 1. If we got any value which is greater than this, then we have to swap with this number. So how we will swap it? First we will get this value index 1 is equal to I, and we will break from this for loop because we got the pointer. After that, we'll be doing swap between these two pointers. Swap will pass the nums, will pass index 1 comma index 2. These two values we have to swap. Once we swap it, then we have to reverse the array, because let's consider these two parts 1 2 3 and 1 3 2. So here we will get the sequence like this, where 2 is greater than 2 is less than 3. So index 1 will be pointing to 2 and index 2 will be pointing to 3. So these two values will be swapping, 3 and 2 will be swapped. After that, if there are any value, then those we have to reverse it, because after reversing it only we will be making as a ascending order. Here we don't have arrow, that's why I have considered four, no, array with four integer. In that case only this logic will work, where we'll be reversing the array, where we will pass nums and index value. From where we have to reverse? We have to reverse from array index 1 plus 1. Will pass index 1 plus 1, because index 1 will be replaced with index 2. So after that, whatever element is there, we have to reverse it. That is done. This is the whole part of finding the next permutation. Let's write the logic for swap and reverse. Public void swap. Swap is easy. We have to take 3 variables, nums, int I, integer. Inside that we will create temp. Temp will be nums of I, then nums of I equal to nums of j, and nums of j equal to num equal to temp. That's the logic for swap. What is the logic for reverse? Void reverse. We will take two pointer here. First one is nums, second is index, we can say. Now what we have to do, we will be reversing, and for replacing, what we will do, we will pick the first element from the start of the array and second element from the last of the array, and those two we will reverse, and we will be incrementing the first index and will be decrementing the last index. So we'll take first as index, we have to start from this index only, and last will be end will be taking as nums dot length -1. If start is less than end, then those two we have to swap it. Swapping, we can call the same method again because we already have same logic. We can call nums, we can pass a start and end, and then we will be incrementing start variable, will be decrementing end variable, because we have to reverse the whole array, sub array, you can say, the array which is exists inside this array. So because you can see the array size max it can be 100, so we have to reverse the whole array. So that's the logic. Let's run this code. You can see I got the answer for 123. The output is 132. First thing is we are finding first pointer at 2, second second value, second pointer at third value, and those two we are swapping, and then we are getting output. We don't have to, the reverse method is not required in this case. Second case, output is 321. When it is 321, we will not find the index 1 value, so it will directly reverse the array. So you can see the reverse is also working. What it will do, 1 and 3 will be swapped, so 1 will be placed at first location, 3 will be placed at last location. After that we will be incrementing start will be incremented here, and end will be decremented here, so that both will be restarted again, then we don't have to do anything, so it will reverse that array. Third case, we have 115. So index 1 will point at 1, index 2 will be pointing at 5. So these two will be swapped. So 5 will be placed at second position, 1 will be placed at third position. And after that, we don't have to do any reverse part. Let's submit this code. You can see it's working fine with all the test cases. Let's talk about time complexity. So here we have created a for loop which will take big of n time. Then again we can say this for loop also can take big of n time. So n plus n to n, that also considered as a n only. So time complexity is big of n and space complexity is constant because we have just created some um, pointers here. We have not created any new array and we are swapping inside the same array also. So we are not creating any extra memory for array. So that's about this nest permutation logic, how we will write the code for this, and we also talked about time complexity. Thank you for watching my video.